Hello students, welcome to LJ Institute of Engineering and Technology. Here myself Mr. Jaiswal Kishan, Civil Engineering Department, and we are learning all about structural analysis. Now in today's session of moment distribution method, we will be studying the concept on sway. Let's start. So there are some points on sway which is known as causes of side sway. So with the help of these some points, these are the 6 points which say the sway will occur or not on the particular frame. So let's move ahead with this conditions of sway. This is way more similar the causes which were came in slope deflection method. So let's proceed. So this is the causes of side sway, in which the first was that different end condition of the column. Means you can see that this is a frame in which this support is a fixed support and another support is a roller support. So there are two different end conditions which say for different end condition of column, ultimately the sway will occur in that particular portal frame. So first condition is different end condition. Whenever you look different end supports, so you can rectify that the sway will occur in this particular frame. So our next point is non-uniform section or MI. Means there is non-uniform of moment of inertia of the particular member of the frame. Now here you can see that here it is in 3i of this column and here it is in 2i for this column. So there is difference in I. Here is 3 moment of inertia and here it is 2i. So by whenever you see this that there is a different moment of inertia, then you can rectify that the sway will occur in that particular frame. So our second point is non-uniform section of a MI. So next third point, unsymmetrical loading, eccentric loading. Now in this frame, you can see there is a different or unsymmetric kind of loading is given. Also a kind of eccentric point load is also given. So whenever you see this kind of unsymmetrical loading or an eccentric loading, you can consider that the sway will having in that particular frame. So our third point is unsymmetrical loading. Here you can see that there is an eccentric loading and unsymmetrical kind of loading is given in this frame. So till now we have considered 3 points. First was different end condition, second was different MI, and third was unsymmetrical loading. So our next fourth point is settlement of the support of the frame. Whenever it is given in the example that any of the support of that particular frame is settling by somewhat amount of delta, like it is having over here, like here you can see this is a fixed support, this is a roller support, and roller support is deflecting by some amount of delta. So this deflection say the sway will occur in the frame. So whenever you see this deflection in the support, so there is be likely to happen a sway. Whenever you see like this support moved over here, so this will try to move like this in a kind of sway. So it says that the sway will occur, means there is a settlement of support, so there is a sway in the frame. Now next point is horizontal loading on the column of the frame. So it is very easy that if a frame is having an horizontal loading, if it is having on a left side, so the sway will occur. If it is having a right side, so right sway will occur. So ultimately, if there is a loading which is horizontally acting on the column, so that condition is a condition of sway. In this condition also sway will occur. Our next point is unsymmetrical outline of the portal frame. Now what is unsymmetrical outline? Means the different length of columns. Here you can see, here the length of column is 3 meter, here the length of column is of 5 meters. So there is a different outline of the frame. So it says that a sway will occur. If there is a difference in column frame, so sway will occur in that particular frame. So these are the list of causes of sway. These are the 6 points we say the sway will occur in our frame. One was different end condition, second different MI, unsymmetrical loading, settlement of support, horizontal loading, and unsymmetrical outline of frame. So this all conditions says that the sway will occur in that particular frame. So we have to remember this all 6 points. With the help of these 6 points, we can rectify that the sway will occur or not. Now one question is, all 6 points must be occur on that particular frame? No. any single point also come, like if there is a different mi of the column, so ultimately the sway will occur. Also only a single point also come, then the sway will occur. It might be happen that it can be two or more number of the point can occur, like as non-uniform mi and different end condition. So ultimately by that 2 point we can also rectify that the sway will occur. It is not necessary to have all 6 points or only a single point. It can be single point also, it can be occurring 2 points, 3 points, whatever. All can be also possible. So by this all points we can rectify that the sway will occur on the frame or not. So now let's move towards the concept of frame. So portal frame with side sway. Now it says in case of frame with loading symmetry and geometrical symmetry, there will be no sway. Means if a frame is there in which it is a symmetric kind of structure and symmetric kind of loading is given, so in that particular kind of frame there will be no sway. The joint of such frames are subjected to only rotation and no translation. Means there will be only a slope kind of thing and not kind of deflection. But if there is a lack of symmetry either in geometry or in loading, means if there is an eccentric loading or if it is an unsymmetric kind of structure, like as if column is having one column is having length 5 meter, another column is having length 3 meter, so unsymmetrical geometry, the sway will occur in that particular frame. So when the joint of the portal frame having sway, a set of moment are likely to produce at the two column head. Means if there is a sway in the frame, the joint at the column head, there will be some moment will occur in that particular joint. So the ratio of the sway moments at the two column heads, that is MBA is to MCD. Means the ratio of that column head MBA to MCD will depend upon its end condition, that moment ratio. So our first case we are considering is case number 1, in which both ends are hinged. Here you can see a frame in which these are my joints which are considered as a hinge joint, and this B and C column heads for which I am talking about, this heads of the column will be happening some moment. So this will having a sway, then it will shift to another position, means a delta position, deflection will likely to occur. So whatever here it is said, the ratio of the sway moment at the two column heads, mean that B and C, the moments like MBA to MCD, these are my column moments, which is over here MBA and over here it is MCD, will depend upon end condition. So its far end condition will be guiding towards the sway. So here our far end is both is simple. So if far end is simple, the moment which we learned in the session 1, that moments 3EI delta upon L1 square, 3EI delta upon L square, which we have studied in formula. So for far end is hinge, the formula is 3EI delta upon L square. So for MBA and MCD, the formula remains same. So the ratio of MBA to MCD is 3EI delta upon L1 square to 3EI delta upon L2 square. Here only the changes in I and L, they may be vary in I1 and I2, and they may be vary in L length also. So the final ratio is MBA to MCD is I1 upon L1 square to I2 upon L2 square. Now we are considering case number 2 for both end is fixed. So for both end fixed, the formula became 6EI delta upon L square. In this also similar, the 6EI will cancel out, 6E delta will cancel out. Only I and L are the varying function. It can be changed, it can be differ for the different kind of condition. So the ratio will be MBA to MCD is nothing but I1 upon L1 square to I2 upon L2 square. So the case 1 was two hinge connection, far end was hinge. Case number 2 was both the ends are fixed. Now let us consider that mixed connection. If one end is fixed and another is hinge, then what will happen? So in case number 3, we will consider one as a fixed and one as a hinge. So here you can see there is a hinge connection in CD, and in AB column there is a fixed connection. So for fixed, the formula becomes 6EI delta upon L square, and for MCD, which is at far end is simple, the formula will become 3EI delta by L square. So the ratio of that will be, now here E will cancel out and delta will cancel out, and I and L1 and L2 will differ, which as I said, Now here 6 and 3 are differ, so 2 will remain at the upper end, so 2I1 upon L1 square upon I2 upon L2 square. Now this is not fixed, this is not every time it is same for both, for one end fixed and one other is hinge. If this fixed support is over at D and this hinge support is over at A, so ratio change to 1 upon 2 into I1 upon L1 square to the I2 upon L2 square. So with the help of different kind of connection, we have to rectify the kind of equation. So now here, one more thing, this delta is also cancelled out because both the column will having a similar kind of deflection. There won't be happen like this will happen a 10 mm deflection, this will happen a 5 mm deflection. The difference in deflection will not be possible because if a amount of loading will given, the frame will try to sway in a same amount of deflection which is occurring at B, the same amount will occur at C. So this we have to remember, so that's why we are cancelling out delta. And elastic property of the material we are assuming as the same, so that's why we are cancelling out E. So the just vary functions are our I and L. So I may vary due to different moment of inertia and L may vary because different length of column. So by this we can find out this ratio, and with the help of this ratio we will try to find out sway moments in the examples, and with the help of that we will try to see that how to solve the examples of portal frame with a side sway.